So, we are now going to discuss concept generation. For generating a new concept, the two key inputs are customer needs and preliminary product specification. That is, a broad specification of the product is required, as well as what we need is what is the need of the customers. So, these two are actually key inputs. Unless these two inputs are really with us, one cannot really give a solution concept for improving an existing product or thinking something which is very unconventional or a completely new type of solution. Next, the concept generation is also a process, and let us look at what are the various steps which are involved in the generation of the concept. So, the very first step is problem clarifications, and within the problem clarification, what do we need to know is to have a very good understanding about the problem, a very clear cut understanding. A fuzzy understanding is not going to help. So, we should be very clear about what exactly we want to design or what sort of design improvement is exactly required. Next part is problem decomposition, that is, decompose a bigger problem into smaller ones. We will discuss about them in more details now, and then focus on critical sub problems. So, first of all, understanding of the problem for which we are looking for a design solution. Then, if the problem is big in nature, we have to decompose the problem and find out what are the sub problems within it, and then only we can think of focusing on those critical sub problems which are most important for the overall performance of the product or an improvement in any aspects of the performance of the product. So, let us go through these steps in little more details. Clarification of the problem. That basically means a clear cut understanding. All right. These steps are also depicted on the top of the slide. So, understanding of the problem is very important, and what we need to know by this understanding, one is who are the users. Any product that we are going to develop, there will be always some users. So, we have to know who are those users. That is, are the users working in a mine, or are the users are firefighters, or the users are working in a factory. So, the users we need to know, and what type of work they are going to do, that means the type of activity of the users. So, what sort of activities in which they are involved, that means the mapping of working environment is important. So, users, are they male or female, are they working at the level operator, or whether what could be the age profile of those users, Are they young people, or are they middle aged or old people? So, all these aspects about the users we need to know. Then come the type of activity of those users. So, which sort of activities they are involved, and that needs to be known, as well as I said, environmental condition, that is the working conditions under which the product is going to be used. So, what is the nature of the working environment, that we also need to know, that is whether they are working in an environment where there too much of humidity is there, or is it a dusty environment, or is it an environment where there are a lot of heat is there. So, these aspects, or that could be too much of cold temperature could be there. So, these working environment, that is temperature, humidity, whether what is the wind speed, is it a environment which is outside in the field, in the mountains, near the sea shore, all these aspects we also have to clearly note down. Then what are the deficiencies in the existing product? We should also make a list of that, that whatever product is there as of now, it may be a product made by a company A, company B, company C. So, if possible we try to analyze and note down the deficiencies, shortcomings in these products. For that we have to do some research, either we do in-house research, or we have to take customer feedback. That is why it is important, the customer needs we need to know. So, customers can also spell out some of the deficiencies which could be there in the product that they are using. So, these are all of them are very, very important, and we need to have a complete information about these aspects. Next is, once this is available with us, then based on these informations the problem has to be defined. There has to be written documentary that what exactly we want to improve in the existing design. That should be clearly spelled out, so that there is in later stage there is no confusion in the mind. And the problem when it is defined, we can have a broad definition, and also we can have some specific definitions. So, a general definition about the problem, and under that general or broad definition we can have some specific definitions, which will spell out exactly what needs to be improved or what needs to be redesigned. That is what is that we have a definition which is split in two parts, a broad one and some specific definitions. All right. From there we have to now go for the next step. So, in a way the specific definition also can be said that they are derivative of basically broad definition. All right. So, let us go to the next slide where there is an example given, and this example is what? This states that, let us say that a certain need statement of a denim user. We are giving a very short and brief example. So, from the denim user we could find out the need statements of the users are: I travel a lot. The next one is I use all modes of transport. Next is I do not find time to wash, because he travels a lot, he moves from one city to another city very frequently, maybe almost half of the month he has to travel. So, it depends about the nature of the job. I use it in both summer and winter, and I like tea and coffee a lot, because he is traveling and he is a loves to drink tea and coffee, he meets his client. So, obviously, most of the times the tea and coffee will be offered. So, he is fond of, or he may be compelled to take, because he is serving some clients or customers. So, let us say that these are the need statement of a person who is going to, he is a denim lover. So, he also uses the denim pants. Now, from this need statement we can write down definition of the problem. So, what do we write? We can write that, so if we translate the need statement into a problem definition, then we can write development of a lightweight, durable, comfortable denim with moisture management, soil and stain resistance properties. That could be the definition of the problem. So, if you see, you can easily associate the definition with the need statements made by the denim user, because he is using the denim for a long time. So, it is better to have a lightweight denim, he is going to feel comfortable, not a heavy one. Then obviously, because of his extensive use of denim, the durability of the denim fabric is also very important. As a customer, there are certain expectations about the life of any product. Then it has to be comfortable one. So, lightweight itself will make it comfortable. We can also think of how to make it comfortable further. So, maybe with moisture management property is one aspect which can be looked into. So, therefore, we write with moisture management and soil and stain resistance, because he loves tea and coffee that can be spillover on the pant or trousers. Therefore, it is better to have his soil and stain resistance, at the same time because he does not find time to wash. So, therefore, stain resistance and soil resistant properties are very desirable in such kind of product. So, that is how from the need statement one can define the problem, and then we can further go for classification of this general problem definition into sub problems also. Okay. From there, we are thinking about the decomposition of a problem. Some of the problems are so complex in nature, are so big, one can think that we need to go for decomposition of the problem. So, complex design problems are to be decomposed in several simpler sub problems. Now, how do I divide? On what basis? One is functional decompositions, which is very important for technical products. So, function wise we can decompose the general problem into number of sub problems. Then decomposition by sequence of user action, that way one can also decompose a problem, or decomposition by key customer needs. So, what are the key customer needs or key performance parameter we can say in a product, and we can decompose the problem based on these key performance parameters or performance characteristics, whatever we want to say. That way also we can decompose. So, there has to be some basis on which we decompose a big problem into smaller ones. So, it becomes a big task into small task. Okay. So, let us say decomposition according to customer need. Let us say as an example, customer need for a firefighter's uniform. So, after making a survey of the existing uniform that are those which are used by the firefighters, let us say we come to know that the firefighters are looking for reduction in bulkiness of the uniform, because that creates maybe hindrance to their activities. So, bulkiness needs to be, it has to be trim type of garment or uniform to be produced. Next is reduction in weight, that is the uniform is probably too heavy for the users. So, whether weight reduction also they are looking for. And the third is, let us say, doffing and donning time. This is something important for firefighters, and they also are looking for a uniform where doffing and donning time can be reduced, so that they can quickly put on the uniform and then rush for the rescue operation wherever there is a fire. So, these are the let us say 3 aspects that the firefighters are looking for. So, this sort of needs are there. So, we can have something like this. Now, decomposition of this design problem could be, one is material selection with a view to reduce weight and bulkiness, because weight and bulkiness reduction is one need. So, how do I reduce the bulkiness and the weight? Through proper selection of raw material, which could be fiber, filament, it could be yarn, it could be fabric followed by fabric. So, is there any possibility? So, that could be one aspect. The other is interlining size and closure designs with a view to reduce doffing and donning time. So, doffing and donning time is also could be in terms of interlining which is being used. So, interlining should be such that the little friction, so that one can put it on very fast and remove it also very fast. Size also will matter. If it is too tight, it will be difficult for the to put on the uniform, because pushing the limbs through the uniform will take more time. So, this is one thing. The other aspect could be performance testing, because once the product is ready with improved design, the next job could be how can we test the performance of this particular product now. So, we can say this is how we can decompose a design problem into different sub design problems. All right. So, there are different ways people can think, but it has to be logical in nature. All right. From there, another aspects we are also showing, this is functional decomposition of a firefighter's uniform. If we go, then material selection is one aspect, ensemble structure is another aspect, fabrication is another aspect, and ergonomics of the design is another aspect. So, that way a firefighter's uniform design can be looked into as if there is a subtask of material selection, another subtask of ensemble structure. So, overall structure of the ensemble, so that the person is protected from extreme radiation hit or maybe from flames. The other one is ergonomics of the design, could be another aspect. So, that person should not feel too hot, or he should be able to work with the uniform that will be given to a person, to a particular firefighters. That means fit, size, these aspects, closures are all related to ergonomics, and the way person, how much physiological load is going to act on the person, and how much freedom the person has while trying to work when he is putting on the uniform. So, these aspects will be coming under ergonomics design aspects. The other one is could be fabrications. But ultimately, the whatever material finally we choose, that we have to fabricate. So, fabricating procedure and what type of thread to be used, what type of sewing machine to be used, what sort of seam to be used, how to join different layers, all these are part of fabrication. So, that could be also another aspects of the total design. Now, focus on critical sub problems, that is, if there are, we find that too many sub problems are there. So, we should only focus on those sub problems which are very critical in nature, on which, and which are critical problems, problems on which the success of the product depends. This will be known as critical sub problems. That means, anything to do with the major performance characteristics of the product, these are critical in nature. For a firefighter suit, protection from heat is most important. So, that anything related to protection from heat will be a critical issue for firefighters clothing. That become the most, so that problem has to be given importance than other minor problems which could be there. The other thing we have to see is resource and time constraint may also compel to focus on few sub problems. So, if from the customer needs, let us say, if we find out there are too many sub problems to be solved, then instead of solving, so let us say there are 8 sub problems based on customer need. Now, we may not tackle all 8 in one go. Instead of, we try to tackle maybe half of them, maybe 4. Which 4? Which are most critical in nature. And why we are doing it? Because there may be constraint of time and constraint of resource. Therefore, we have to bring it down from 8 sub problems to 4 sub problems, or maybe 5 sub problems, whatever it is. Now, from there we go to the next step of the concept generation, that is searching. Now, after knowing what has to be done, next we have to go for search to find out solutions. So, one of them is external search, the other one we have not shown it here is internal search. So, under external search we have to approach the following people or following aspects. One is we can go to the lead users and talk to them. We can consult experts in that field. We can go through the patent informations, so patent survey. We can find out the relevant literature by consulting different journals, different magazines, different reports, and we look for benchmarking informations. External search, that basically means what there exist any existing solutions or not. So, if the solution already exists and available somewhere, if we find it out, then we try to implement that solution first. This will help to spend more energy on those critical problems for which solution does not exist. So, initially we try to find out a solution that already exists, and to find out we have to consult experts, we have to consult the patent literatures, or we have to go for informations by reading different journals. So, that is how we can find out some solutions which are already existing, or we may also study the competitor's product with respect to that particular problem and see what sort of solutions or what sort of thing they have done. That is what we should do. The reason is, if solution already exists, I implement it. Where solution does not exist, we can concentrate more time and energy on those issues. The external sources are, as I already have stated, expert consultations. There are some consultants in many fields who have lot of experience. So, we try to identify them and discuss with them about the problems. Patent search, I have already said, search published literature and study existing similar products. That is how these are the various sources of informations. That is the external search. Next comes internal search, that within the organization also we look for solutions. That is called internal search. That is, we try to consult people, suppose who are working in the organization in the production area, or people who are working in the marketing. So, such people, or even in the design team, if we have some members, we ask or each member to propose certain solutions. That is what is called internal search. So, internal search guidelines are that you ask your own people to generate ideas. So, in the design team, if there are 5 people or 10 people working together in the development area, then we request that each one of them will come out with an idea, so that each participants in this design exercise will feel that they are also involved for finding out the solution to the design problem, and we encourage the people to develop lot of ideas. And here there is no hierarchy, everybody in the design team will be asked to develop idea, and all ideas will be welcome. Whatever, even if it feel infeasible. Therefore, initially idea generation is the motto. That is what we should, therefore, we should always encourage people to generate ideas, and we will always, now we should not bother whether the idea is infeasible to start with or not. Use graphical and physical media sometimes to translate the idea. Either people can write in text form, or people can use graphics. So, the others are that one can make a physical model. So, sketches, foam, clay, cardboard, any other 3D media, computer graphics, or any other software where we can have a 3D design we can use it to communicate with the other team members. That is how now we should try to develop the solution ideas within the organizations. The important point is that lot of ideas can be generated internally also. There may be some people who may not be in the design team, who may be outside the design team also can give you some very interesting input. So, therefore, this is what has to be also tried. So, that is what is known as internal search. After having done this, now we go to the next step, existing concepts and new concepts. What it is? While trying to develop solution concepts, we can take the help of analogies. That is, look for natural or biological analogies to the problem. When no idea comes to the mind, then we bank upon the nature. So, we try to find out whether a similar analogy exists in nature or not. If something is there, we try to study it and try to get informations and analyze it, and then we can generate idea out of it. One of them is lotus effect, which many of us have already read, that lotus leaves are such that there is no dirt on it, because whenever there is a dirt and the water, if it falls on it, it will roll down very easily. It is a highly hydrophobic surface. So, as the water roll down, if there is any deposition of dust particle on it, it will take away the dust along with it. So, a lotus leaf always remains clean. Or we can go for biomimicking, that is, whatever solution nature has given to certain problems, we study it and try to mimic it in our designing or giving solutions to a design problem. This is very, very common, and studying nature in order to find out a solution is so common in many fields. In textile also there are many examples. So, I will also show you another example. The other thing is encourage member to generate ideas. Each member can generate a list of solutions or ideas working alone. So, that means the person should not be influenced by what his boss is saying. Every individual can be given complete freedom to think about a solution, and the solution can be passed on to his neighbor or to his colleague. Similarly, the colleague can pass on his solution to the other person. That means, everybody gives a solution and they themselves are scrutinizing the solution, because they are sharing the solution with each other. And upon reflection on someone else's ideas, most people are able to generate new ideas. What happens sometimes that some people will say, no, I have no idea, there is nothing coming in my mind. But then when someone proposes an idea, suppose in a group type of activity, one person in the group proposes one idea, solution idea. Now, the other member, they then start thinking. That is, their thinking process starts when he finds an idea given by one of his colleague. So, that a person who was passive till now will start giving solutions also. So, that is what also happens, that when you see someone saying something or someone giving some idea, then something triggers in your mind, and you also can now give some other argument, or sometimes you can also develop some other idea. So, the triggering effect is there at times when someone starts with an idea. That is what happens also in many situations. Now, we are trying to narrate a story of Velcro development. Velcro is a pure textile product, and you see the application of Velcro. Now, let us read this particular paragraph, it will be very clear to all of you. In the early 1940s, George de Mestel, a Swiss inventor, went for a walk in the forest with his dog. Upon his return home, he noticed that the dog's coat and his trousers were covered in cockle bars. His inventor's curiosity led him study the bars under a microscope, where he discovered the hooked ends of the bristles that stick out from the seeds. So, he found that the hooked end of the bristles. This basis became the basis for a zip, later developed into two-sided fasteners. So, because it is hook type, it was getting entangled to the fur of the dog, or to the to his pant also, because from our pant there will be a lot of projecting fibers, is basically hairy surface. So, it was basically getting attached, and the mechanism of attachment was because they are all these bristles had a hooked end. So, what he did, because immediately from here he got the idea. So, one side has a stiff hook like the bars, the other side has a loops. He developed a fabrics, or basically two fabrics. One side of the fabric had stiff hooks like bars, like in this case this one has loops, and this fabric is having hooks. So, hooks are here and loops are there, and therefore, when you bring them closer to each other, then once they mesh, there is a entanglement. The hooks get entangled with the loops which are there in the other surface, like as shown in this diagram, and as a result they stick to each other. So, the idea came from basically from the nature. So, this is one very interesting example. Similarly, there are many more examples which are there. Another interesting example of the design is hiking socks. Z. Threnborg, the chairman of Thorlow Incorporation, was suffering from overweight. This gentleman was suffering from overweight and having trouble with the exercise routine he had begun. He recognized that the problem was caused by his feet, which hurt from walking and jogging. So, he could recognize this, that the problem is because of this feet, which is getting hard because he is fond of walking and jogging every day. So, he wanted to now find a solution. So, he and the design engineer developed a new kind of extra cushiony socks, that is what was developed, that had a padding placed to absorb shock and prevention or prevent friction. Therefore, here he added, it make some padding here. So, whenever I work, this heel part comes into contact. See, there is always a impact at the heel portion, and if we want to reduce the intensity of the impact, this we can have a padding over here. So, that is what he did it, and the sock became very, very useful, and he called it hiking socks. The hiking socks became very, very popular. It is comfortable, its breathability is there, and it had added protection against blistering and abrasion, firm feet and reinforced heel. So, that is how when a need arises, a person start thinking, and after thinking he tries to find out a solution, and the solution leads to developing a new product. After this, we come to the last step, concept selections. So, once we have, suppose people have developed quite a few concepts, solution procedures or solution concepts. Now, we have to go for concept selection. So, what to do? List the strength and weakness of each concept. So, if there are a couple of concepts generated by different people, then people should sit together and try to list the strength and weakness of each concept. We should verify whether the customer needs have been met. So, each concept is there. So, we will try to ask these questions and seek answers. Whether the customer needs have been met. Number 2, what is the market potential, because ultimately any product has to succeed in the market. So, whether marketing potential exists or not. So, assessment, we may need some people from the marketing team to assess this aspect. Identify any shortcomings which may be remedied. So, if there is any shortcomings with the existing ones, that could be a possibility of finding a better solution for it. The other thing could be also that combination of concepts. Suppose for sub problem 1 there are 3 solution ideas, for sub problem 2 we find 4 ideas, sub problem 3 there are 2 ideas, sub problem 4 there are 3 ideas. So, the possible solutions we will have then how many? 72. If we combine them, these ideas, then we can have 72 different possible combinations. Now, this is something which is not really feasible. So, we have to work out something sometimes that can I combine the concepts or ideas that have been generated by different people, so that possibilities of combination has to be looked into. And what to do about this? Now, eliminate those ideas, because so many combination is not practicable. So, therefore, we will first eliminate those ideas which are infeasible through a brainstorming session. So, through brainstorming we have to find out, can I reduce sub problem ideas 3 to 2 or 1, sub problem 2 ideas 4 to 3 or 2 to 1, like that. We can trim down the number of solution ideas, because some of the solution ideas may be infeasible to start with right at the moment, because of constraint of technology, constraint of material availability or things like that, whatever. People has to decide, can I bring it down from 72 combinations to something which is less, and then find out what is the most promising combination. So, you should choose for maybe 3-4 promising combinations. The combination may need further refinement before integrated solution appears. This is also possible, that even after combination we have to see the compatibility of the solution ideas for different sub problems, and then maybe we can further refine it before we find out an integrated solution. So, once we ultimately reach few solution ideas, now we go for prototype development. So, develop a prototype based on the preliminary design specifications. Specifications will now come, and we have to, because we have to finally meet the specifications. So, that based on the specification or keeping in mind the specification, we have to develop prototype, and so once the prototype is developed, we go for testing and refinement. That is, we test it in house in the own laboratory, or if some test facility does not exist, we seek outside help, but we try to evaluate. So, evaluation has to be done, and then if there is a requirement for refining either the specification or the design, we will do that. Then we go for actual field testings by the customer at their own user environment. So, we make some more prototypes after refinement. So, once we succeed at the laboratory level, then we go to the outside, that is, we go to the customers and ask them to use it. So, in their own user environment, it will be tested. This is called field testing. The goal is to know about performance and reliability in order to identify necessary changes in the product. That means, we have still not frozen the idea, the design idea or the specifications. So, after field trial, if we find there is a need for further refinement, because in some aspects probably it has failed or it has not been able to give you a value which you expected, you need to then redesign. So, redesign means either the idea refinement or material changes or fabrication procedure, whatever could be there, or specification modification, whatever it is. That is what we should do after field testing. And once that is done, that once the field testing data is available, and now we modify if required some aspects of the design, then we set the final specifications, that if I use this type of design and these are the material I use, this is the fabrication process I use, that is the sort of values I will get for different performance parameters, and that becomes my final specification of the product. So, the target specification is set earlier, therefore, are revisited after a concept has been selected and tested. So, that may be required. The team must set specific values reflecting the constraint inherent in the product concept also. Limitations identified through technical modeling and trade off between cost and performance This is what is also important, that if there is some constant inherent in the product concept, the team is going to set specific values. This is what is achievable with this particular design concept, and we cannot really go attain a value which is beyond this or below this, whatever it could be, and what is the corresponding cost for this. After that, the development plan is made, that the team develops a detailed development schedule and identifies resources required to complete this project. Then the development plan, complete plan of manufacturing, selling, everything then comes. After this, production of a small lot. So, a small lot is produced actually. Sample production is made using intended production process. Why do we produce a small lot to start with? Because idea is to train the workforce and sorting out problems related to the production process. Instead of going for a very large volume of products to start with, we go for a small volume, so that we train the workforce accordingly if it is required. The other thing is production related problem or process related problem that may arise. Suppose we have changed the raw material, so there could be some problem related to the process now, and therefore, you need to fine tune the process again, and therefore, we initially go for a small lot production. The transition from production ramp up to ongoing production is gradual. So, after doing this, when we see that yes, the problems related to the processing or process related have been sorted out, and the workforce also have been trained for this particular product concept as far as the fabrication or production procedure is concerned, then we actually go for large scale production. With this, we close this particular session. Thank you.